Now, I know what you're thinking. What's a convex lens? Haha, okay, I doubt that's what you were thinking, but let's start with refraction. You learned back in the 5th grade, refraction was the bending of light when you saw a pretty little rainbow. Refraction is the bending of the path of a light wave as it passes from one material into another. Refraction occurs at the boundary because it's caused by the change in the speed of light wave upon crossing the boundary. The tendency of a ray of light to bend at a certain direction is dependent upon the speed of the light wave, if it speeds up or slows down while it's crossing the boundary. The speed of a light wave is dependent on the optical density of the medium it passes through. The direction that the light bends on depends on whether the light wave is traveling from a more dense medium to a less dense medium, speeding it up or from a less dense medium to a more dense medium, slowing it down.
To understand how lenses refract light, we can refer to the FST and SFA principles. The FST principle refers to if a ray of light passes across the boundary from a material in which travels fast into a material in which travels slower, then the light ray will bend towards the normal line. The SFA principle refers to light rays traveling from a fast to a slow medium. SFA. Think of lenses as a series of tiny refracting prisms. Each of them refract light to produce their own image, so when they're all placed together, they produce one bright image focused on a point. We have two categories of lenses, convex and concave lenses. The difference is accounted by the shape. A convex lens is thicker across the middle and thinner around the edges. It converges light rays that are traveling parallel to the principal axis. Diverging lens is a lens that diverges rays from light that are traveling parallel to its principal axis. Diverging lenses can also be identified by their shape. They are relatively thin across their middle and thick at their upper and lower edges. Any incident rays traveling parallel to the principal axis of a converging lens will refract through the lens and travel through the focal point on the point opposite of the lens. Any incident rays traveling through the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis. True rules of refraction of diverging lens states that any incident ray traveling in parallel to the principal axis of a diverging lens will refract through the lens and travel in line with a focal point, and any incident ray traveling towards the focal point on the way to the lens will refract through the lens and travel. Diverging lens is a lens that diverges rays from light that are traveling parallel to its principal axis. Diverging lenses can also be identified by their shape. They are relatively thin across their middle and thick at their upper and lower edges. The true rules of refraction of diverging lens states that any incident ray traveling in parallel to the principal axis of a diverging lens will refract through the lens and travel in line with a focal point, and any incident ray traveling towards the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis.
The terms associated with lenses and diagrams are the principal axis, focal point, vertical plane, and focal length. The principal axis is the imaginary horizontal line that symmetrically cuts the lens in half. The vertical axis is the imaginary vertical line that bisects the lens in half. When incident light rays converge, they intersect at one point known as the focal point. If the light rays diverge, then they can be traced back to a point in which they intersect, and that would be the focal point in a concave lens. In ray diagrams, there are two focal points on each side of the lens, and both are denoted by a letter F. There are two focal points because the lens